There are over 480,000 school buses in the United States. They travel 12,000 miles per bus each year on average. The buses usually run on diesel fuel and get only 7 miles per gallon. Their exhaust emits many pollutants into the environment, which can cause health effects, especially in lungs, and add to global warming. Global warming contributes to melting polar ice caps and rising temperatures. We need an algae tube filtration system so we can reduce particulate matter and carbon dioxide emissions to prevent global warming and keep people healthy. There are other ways to reduce emissions, like changing fuels, preventing idling, retrofitting other filters. Federal regulations have changed, so bus fleets are expected to change in 15 to 20 years to meet standards. In the meantime, or long term, the algae tube filtration system will improve exhaust. We presented our project to Mr. Corliss, owner of the Center for Efficient School Operations, who specializes in transportation. He gave us feedback on implementing the system.
Each year, one bus emits 7 pounds of particulate matter, 32 pounds of hydrocarbons, 353 pounds of nitrogen oxides, 108 pounds of carbon monoxide, and 51,700 pounds of the main pollutant, carbon dioxide. Particulate matter is small particles and liquid droplets that cause lung and heart problems. Hydrocarbons and nitrogen oxides contribute mainly to ground-level ozone. Carbon monoxide can harm humans, and CO2 contributes to global warming. The algae tube filtration system focuses on particulate matter and carbon dioxide because they are the worst for the environment and health.
All growing plants absorb carbon dioxide. Some plants absorb more of it quicker. One of these plants is algae. Scientists have shown that algae can absorb anywhere from 30 to 50% of carbon dioxide out of exhaust from power plants. The absorption rate depends on the algae type, its growth rate, the amount of sunlight, and temperature. Algae also breeds rapidly, allowing for more carbon dioxide absorption. Scientists have discovered that algae that have absorbed carbon dioxide may be pressed to create biodiesel or dried and burned with or in substitution to coal. We presented our project to Dr. Min, an algae scientist with the Department of Bioproducts and Biosystems Engineering at the University of Minnesota. She is researching how algae absorb different pollutants. Dr. Min agrees the type of algae we use can stay alive in temperatures up to 162 degrees Fahrenheit, similar to algae found in hot springs, like at Yellowstone. Hot springs algae thrive at over 60 degrees Celsius, like certain Sinococcus strains.
How does the algae tube filtration system work?
The exhaust flows first through the Donaldson low nitrogen oxide filter muffler, located underneath the bus. The low nitrogen oxide filter removes 90% of the particulate matter. The exhaust then flows into a clear tube mounted on the side of the bus filled with algae. The algae take out 30 to 50% of the carbon dioxide and produces oxygen. As long as the temperatures don't get above 162 degrees, the algae will not die. The exhaust will be about 300 degrees before it after it leaves the low nitrogen oxide filter, but as it flows through the exhaust pipes, it cools before reaching the algae. However, if the algae do die, then you can simply dry and press them to make biodiesel. This simple process can remove 75% of the oil in the algae. The heating coil in the algae tube will keep it from freezing. The low nitrogen oxide filter costs $13,000, and the algae tube filtration system costs $40. But you do not need to buy the low nitrogen oxide filter to have the algae tube filtration system work.
We have a what?
Get over.
We have a
filter for you. It's full of algae too.
Let's keep the
Yes.
Can we cut this out? Can you guys edit this part out?
Yes.
Okay, so let's start again on 1, 2, 3. We have a filter for you.
It's full of algae too. It gets rid of CO2. Let's keep the environment green.
It'll keep your lungs clean. So get this awesome machine.